Welcome back to Euclidean Geometry, grade 10. Here we are having a problem. Let's read the statement together. In the diagram below, PQRS is a parallelogram having the diagonal PR and SR intersecting at M. So we are having this given as a parallelogram. And once this is a parallelogram, we just know from the beginning that this is going to be equal to this, and this diagonal is going to be equal to this, because you know that in a parallelogram the diagonals they bisect each other, and these opposite sides they are given to be parallel to each other. That's fine. Now, what are we having? B is the point on PR. B is the point on PQ such that SBA and RQA are the straight lines, and SB is equal to AB. So we're having SB. Let me just have SB is equal to BA. We are having those ones. These two lines are given to be equal to each other. So SA cuts PR in C and PA is drawn. Now, this is what we have. So the idea is to prove that SP is equal to QA. SP, which is this one, is equal to QA. What we have, we only know that SPQR is a parallelogram. So this is just what we know so far, nothing else. But in a parallelogram, the given parallelogram, we know that this side is equal to that side. That is what we know. Then another thing is that this side SB is equal to the side BA. So these are the equal things that are given. So what is the information that we really have to take now? And we know that this line is parallel to this one. Now we're getting something. Now you can see that this what is this? This B is the midpoint of SA. This B is the midpoint of SA, because SB, which is this line, is equal to that line. So this is what is given to us. So, and this line is parallel to this one, and we don't know anything about Q, but we now remember that there is a converse theorem of a midpoint. We're having the midpoint theorem, which says if there is the line drawn from the midpoint of two sides of a triangle, that line, if we are having this kind of thing, if the line is drawn, let's say this line DE, if the line is drawn from the midpoint of two sides of a triangle, you can see now that D is in the middle of AB and E is in the middle of AC. So if that is the case, this line is automatically parallel to the third side of the of the triangle. So this is what tells midpoint theorem tells us. Okay, if this is the case, this case, then therefore this line is parallel to this one. So now the converse of this midpoint doesn't tell us about the other side being bisected, but it tells us that we are having one line. If the line is drawn from the midpoint of one side of a triangle parallel to the third side, then therefore it has to bisect this side. So this is what we have. This is a scenario that we have now. That, let me just wrap everything. We know that in this triangle, let me just draw this triangle. We're having this triangle. And we know that this side is equal to this side, and we know that this is parallel to this one. So that makes this side to be equal to this side. What is the reason for that? That's the converse of midpoint. Midpoint theorem. So we have proven that this side, you remember that SP was equal to R cubed, because these are the opposite sides of a triangle, of a parallelogram. That was given. Then therefore this one also equal to that one. Reason that's the converse of midpoint theorem. So we have already done that. To that, SP is now equal to this one, because if SP is equal to RQ and RQ is equal to QA, which means QA is also equal to that same thing. So we have done that. So how do you then present that? Because the presentation on its own, it matters, because people may understand and see what this, how this side equal to this one, but failing to write that down can affect you a lot. Now you are having USP or PS being equal to RQ, reason opposite sides of parallelogram. Then you have what you have, we have this one being equal to this one, and since this one is equal to this one, then therefore, and this one is parallel to this one, then therefore that makes this side, that makes Q to be in the midpoint of AR. That Q is in the midpoint of AR. The reason, that's the converse of midpoint theorem. Now what are we having? We are having QA being equal to RQ. Reason, that's the converse of midpoint. Then therefore SP is equal to QA. They are also equal to RQ. Reason proved. Done with this one. So you just need to figure out whether you have midpoint theorem in this bunch of parallelograms, because sometimes the diagram may be hidden mostly to some kinds of lines, and you may not necessarily see whether there is a triangle there. But like enough, we notice that there is this triangle SAR, where we have recognized that there is a midpoint theorem acting on that diagram. So that is why we figured out that QA is equal to RQ, because of the converse of midpoint theorem. So we are done with that one. Let's come to SPAQ. Let's prove that SPAQ is a parallelogram. Let's move to SPAQ. Let me wrap everything. SPAQ. Let's prove that it's a parallelogram. So how can this be a parallelogram? Let me wrap this first. How can this be a parallelogram? The idea is that we are having this side being equal to this side. We have already proven that. And this side is parallel to this side. It is shown right from the beginning that this line is parallel to that line, so it continues to be parallel. And no matter how long the line is, if it was parallel from the beginning, it is continued to be parallel until further notice. Then what are we having? We have this line being parallel to this one and equal to each other. So the idea is to know that one theorem around parallelogram is that if one pair of opposite sides in a quadrilaterals are equal and parallel, that quadrilateral is a parallelogram. If one pair of opposite sides are equal and parallel in a quadrilateral, then that quadrilateral is a parallelogram. So we just need to know if we are having this as a parallelogram and this is said to be parallel to this one and the sides are also equal. If the sides are parallel and they're equal, then this is going to be a parallelogram. So we are done. So you can either prove two pairs of opposite sides are parallel, or two pairs of opposite sides are equal, or one pair of opposite sides are equal and parallel. So that what makes a quadrilateral a parallelogram that way. So the fact that QA no SP are equal and parallel, then therefore they meet the property of a parallelogram. Wow. So how do you then present that? SP is equal to QA, reason, proved. This is what you prove. It's not given, proved. Then SP is parallel to QA, reason, that is given. So if that is the case, then therefore SP AQ is a parallelogram. Reason, the opposite sides are equal and parallel. So one pair on opposite sides, you can just say one pair of opposite sides are equal and parallel. So you don't have to prove both pairs, né? One pair is enough. If one pair is equal and parallel, then therefore that quadrilateral is a parallelogram. So we are done by that. Now let me just wrap it off for number 3. What number 3 says? Number 3 says you have to prove that AR is equal to 4 MB. AR is equal to 4 MB. That's 2 marks. That's 4 marks. So what we have MB. Now MB. And if we can continue, this is MB. This is another MB. So if you can notice that this line has to be equal to this line, because of course the distance between parallel lines has to be equal throughout, right? So when you are drawing this one, this is MB, this is MB, this is 2MB. So this one is the same as 2MB already, right? So, and we knew that RQ is equal to QA from the beginning. We did prove that. So if this is MB, if it is 2MB, this is also 2MB. So really AR is what? Is 2MB plus 2MB, which gives you just 4MB. So you can just talk about that. Okay, if you are having MB, you have MB, so QR is 2MB, and so then therefore QA is gonna be another 2MB. That makes this whole line to be just 2MB plus 2MB, which is just 4MB. So you can approach it that way or the other way around. It really doesn't matter how you go about solving it. Then this is it for 4 marks. How do you represent that? So it was given as in the diagram that you are having this MB construct, having MB and as the middle, then if you can expand to that corner, you could see that you now have another MB that gives you the whole OQ to be 2 MB. So OQ was given to be equal to OQA from the beginning. So you can just now add them up and find that you have 2 MBs. So that's how you can practically solve it. The idea is to know the properties of parallelograms and be able to work around with the theorems that the uniqueness of these theorems, which how are they going to help you. And also remember the midpoint theorem whenever you are having these kind of diagrams, so that you don't get stuck because you forgot that there is something like that. And having that being said, thank you for watching and see you in the next video.